through phone. You know, there is a QR code, you can scan it and you will be able to participate. Thank you very much. I have now received it. I'm going to share my screen now. Yeah, are you able to see the first slide?
Yes.
Yeah. Okay.
Yes, we can see this one.
Yeah, thank you very much. So this is just an introduction to generative AI and how you can use this in your research. It's bioinformatics or whatever informatics work you want to do. How can a scientist use this in your regular work? This is the whole intention of this. Alex already discussed it. We go a long way, probably more than like 10 years. And this is just a journey of my career, going from India to UK to some places in the US and back now to India, specifically in Coimbatore. I will skip the details because the discussion is not about me, it's about you guys and specifically about generative AI. In that, I want to ensure, as I just told already, this is a live demonstration. Please scan this QR code. You will get a link. When I ask a question, you will get a link. You will be able to participate so that I know, and it is live, so that I know what you think about the questions that I'm asking. And there's nothing tricky or anything, it's just for me to understand. Today's talk is to show you the capability of generative AI, how you can use this for your own research, to do innovation, to do science research, etc. And then also probably briefly tell you the limitations. The intention is to show you the application, not necessarily go into the depths of mathematics or programming or anything. So the intention is to use this as a tool. And I might be telling you just one example or one particular example of a technology, but not necessarily that's the only thing that is available. There are many other things. So to start with, the initial demonstrations will be on freely accessible tools. But at the fag end, I will also show you some advanced features for which you will have to pay. But the intention is not to promote that you have to buy this software or anything like that. It's just to show what is it capable of already today. And whatever I'm going to show, even if you are not paying for it, it will be free. You will be able to use it and to enhance your own capabilities in the free version itself without having to pay. As I said, there will be a lot of interactive polls. So I will go with the first question. I'll just okay. I have already started receiving. Yes, I've already started receiving your answers. Thank you very much. So yeah, most of them prefer water and tea. Yeah, I'm a tea drinker myself, so I'm happy to see tea is one of the top things. It's just to know whether you are able to respond or not in live. And I saw things are changing. Great. So I will just go to the next slide. So we shall start with generative AI, for which we have to first understand what is AI. So what is artificial intelligence? Artificial intelligence is very abstract. It is like love. The concept of love is too abstract. I can use the word love in many ways. I love my country, I love my mother, I love my dog, I love football, I love cricket. So the same word can mean completely different things based on how you use it and the context. So I cannot say I love my country the same way I love my dog. Doesn't really make any sense at all. So in AI field, there is no consensus of what is the perfect definition of AI. So nobody agrees on what is AI. It is just too abstract. It depends on the context. So some of the examples of AI applications that you see is like Alexa or Siri, if you're using them, robotics, drug discovery, weather report, many more things. So within this AI box, there is another box called machine learning. So this machine learning sits within artificial intelligence, but machine learning has a concrete definition. So the definition is the ability for a machine to learn based on the data provided. That is what is machine learning. So that everybody agrees. Like all machine learning or scientists or experts in this field agree that machine learning is a concrete field. So some of the examples are like friend recommendation over Facebook or LinkedIn or Instagram, etc., or book recommendation, time series analysis, etc., etc. So these all come from machine learning. It's a very concrete and clearly defined field within AI. But within machine learning, there's another box called deep learning. Deep learning is a special kind of machine learning. There are many kinds of machine learning, like statistical analysis is also a kind of machine learning. There is classical machine learning, etc., etc. But deep learning is a very specific kind, and you might have often see this in use, like if you have face recognition over your phone or your laptop. This is a specific kind of deep learning algorithm that will be used for recognizing your face. Or voice recognition, if it is Alexa or Siri, it's a specific kind of deep learning algorithm that have been trained to recognize voice. The deep image or fake image is another thing that has come very recently. I'm assuming you are familiar with the incidents of Kajal and Rashmika Madhyana's deep fake images that was generated over the internet and become nasty and a sensational news, unfortunately. So these are all coming from deep learning. It's a specific kind of machine learning, but deep learning is revolutionizing everything. Deep learning has existed for almost for many decades actually, but most importantly in the last 10 or 15 years, it has got a lot of recognition and use because of computing power. But anyway, we will stick to the application side of it. So within deep learning, once the algorithm has learned using deep learning techniques, it is now able to generate. This is where deep fake images is one example wherein it can generate images which looks very much realistic, but it's actually fake, but it is generating. So this is a classic example of generative AI. It is an artificial intelligence, but it is generating images, text, whatever. So this is a box within the box within the box. So this is how generative AI is placed within the big context of AI. One of the classic examples of generative AI is ChatGPT. So I will tell you, before we go to the generative AI, I want to set another context of why this is becoming very important right now. So to understand that, we have to actually take a step back and look at the history of AI, what has happened historically within AI field. For many years, we had what was called as artificial narrow intelligence, which was machine learning. They had very specific purpose, and only for the purpose this algorithm can be used. But now we are in the cusp of artificial general intelligence, wherein the same algorithm can do many things, just like human beings. It is almost very difficult to say whether this is a robot or this is a human being. If you are looking at just the responses, it might be very difficult to say. This is what is called general intelligence. We are at the dawn of artificial general intelligence already because of generative AI. And the super intelligence is where AI is much superior than human beings. So some of the examples I can give is in ANI, narrow intelligence. Example, Siri. Siri can only recognize voice, and that's the only way you can interact with it. You cannot ask Siri or Alexa to draw a diagram for you. It will not be able to do it. It is meant to only recognize voice and appropriately process that information. Similarly, face recognition algorithm. You cannot sing to your phone and say open your lock. It can only recognize your face. That is narrow intelligence. It is meant to only to recognize image, only to recognize voice, etc., etc. In general intelligence, as I said, ChatGPT is one example, but ChatGPT is just one example of a large set of generative AI tools which are collectively called as large language models, which is LLMs. These are completely revolutionizing everything we do as of today. I will come to LLMs in a minute. And super intelligence, we don't have it. At least I don't know whether we have super intelligence right now. But you can imagine movies like Terminator, Robo, Indiran, Her. If you have not watched Her movie, you should definitely watch it. It is not the Hindi movie, but the English movie, which was released probably 7-8 years back or so. And obviously, Wall-E. All these are examples where robots or machines are a lot more superior in their capabilities than human beings. So we are in this stage right now. We are in this stage. We have already moved from narrow intelligence to intelligence, and that is a huge step in humanity itself. I will show you why. To understand that, we have to first understand how this has been made possible. This has been made possible by LLMs, large language models. So what is LLM? So you have to imagine, you can imagine LLM as some Rishi, some highly learned person who has managed to read everything that is there in the world. Every religious textbook, every history textbook, every math, science, anything, philosophy, whatever it is, or every text this person has read. So you can imagine LLM as one such Rishi or Guru, or somebody who has managed to learn everything. And now you can ask questions to this person, and because this person knows everything in the world, at least in the publicly available www.web internet world, he will be able to tell you or give you answers. And that is where is the generation part coming. He has managed to learn everything using deep learning algorithms. And now if you ask questions, this LLM will generate answers for you. And this is the biggest capability LLMs have. It will generate answers in many, many, many ways. And it is best shown using an example. But before we go to the example, I want to know whether you are familiar with ChatGPT. I'm assuming because ChatGPT is the most widely shown or used, or at least in the media, people have shown this. I want to know whether you have used ChatGPT, and how often have you used it, or if you have not used it, it's fine too. We will explore it today. Yeah, I have. I see many people already using it every day, which is a good sign. Which means you are adapting technology, and also seeing people, somebody using it rarely. That's fair as well. So India is known to adapt technology very well. So this is the UPI. Money transfer is in India. The mobile revolution happened in India. Software revolution happened in India, and I'm sure generative AI revolution will also the adaptation of this is already happening in India greatly. And the proof is right there in front of me, in your own front of your eyes, because you're using it almost already every day. I'm happy to know that. So we will go to the next slide. So the best thing to show is through a demo, because that is where I can actually show you the capability. To show the demo, I will go to this the chat bot. So this is a generative AI example, which is ChatGPT. I will start with free version first. I'll be starting with the free version. So I will just ask, because I'm actually living in Tamil Nadu for the very first time in the last 1 year. I have never lived in Tamil Nadu. This is first time I have been here. So I'm going to ask the question. See, what places are best to visit during a trip of Tamil Nadu? And I'm asking this. Okay, let me just remove this and just ask this question just like this. Okay, it is telling me, oh, Chennai, Mahabalipuram, Pondicherry, Tanjore. I'm not expecting you to read it, so don't worry. I'm not reading it myself. Kanyakumari, Coimbatore, yeah, I live there, so I'm happy to see that as well. Coimbatore, Kodaikanal, etc., etc. Yeah, fine. Now, there are many things, but I want it to be more personalized. So now I will ask a slightly updated question. I will ask, answer as though I am a 5-year-old boy, 30-year-old professional, and 60-year-old retired person. So now I want to know whether it will give the same answer or slightly different answer, because my context, the question is slightly updated with more context. I will just ask this question. Let us see what it has to answer. Again, this is all free. You can also try this yourself. See, it is telling for a 5-year boy, it is telling go to Chennai's beach, Marina Beach, Mahabalipuram, and the zoo. Okay, if it is 30-year-old professional, it is telling, okay, probably I will like IT park, nightlife in IT park, and historical sites in Mahabalipuram, adventure. See, it did not tell me adventure if it was 5-year-old boy. See, it has already understood the context and telling me, depending on who I am, like if it is generally a 30-year-old person or a professional, these are the things that generally they will do, like water sports, like Kanyakumari, etc. And if it is a spiritual journey, again, it is assuming at 60 years, probably I'm more interested in spiritual journey, going to temples, etc. He's telling me, oh, go to Tanjavur, Madurai, rituals, etc., etc. Or in nature, you can go to Ooty, Kodaikanal, and cultural experience, traditional music, dance performances in Chennai. So it is giving completely different answers based on the question which is slightly updated. So this is the capability of ChatGPT, generally generative AIs, on how it can answer very differently depending on the context I give. I'll just give you, just to show you further. I only have 1 day to travel. So then, then I cannot go to Ooty and then go to Kanyakumari. That's not possible. So now I'm asking it once again, okay, I have put one more limitation on this. So now it is telling, okay, go to Chennai. Within 1 day, you can cover both of these things. If it is 30-year-old professional, go to, okay, Mahabalipuram, only go to Mahabalipuram, and that's it. It is suggesting. If it is 60-year-old, it is telling, okay, go to Tanjavur, go to Brideshwara temple and surrounding areas. Now there is no Kanyakumari here because it's not possible to go from Tanjavur to Kanyakumari in 1 day. So like this, it is updated. I can keep adding more and more context to the question, and the answers are likely to be very different depending on the questions that I ask. This is one of the capabilities of a generative AI and the questions you ask. So I want to show you another side of ChatGPT or LLMs. I'm assuming most people are familiar with Onion, or at least this movie called Fight Club. What happens is, in this movie, is the same person or the character has multiple personality disorder. They will answer very, very differently depending on how they behave. So I'm going to ask this question: explain PCR, polymerase chain reaction, as though you are Warren Buffett. He's one of the greatest investors of all times, a business leader. Venki Ramakrishnan, who got Nobel Prize for solving the structure of ribozymes. And then Vadivalu, one of my favorite comedian. So let us see what it has to answer if I ask this question. So explain polymerase chain reaction. I'm going back to this. I'm just opening another one. Yeah. Explain. I'll just make it more explicit. So as though you're Warren Buffett. Warren Buffett is a business leader. I don't know whether he knows PCR or not. So it is going like crazy. It is explaining what is polymerase chain reaction, and might approach powerful scientific technique. See, it is picking investments because Warren Buffett is known to invest. He's an extremely good investor. So it is picking investment as an example, and it is telling many more details, and I'm not going to the details of all of these things. See, it is telling me, emphasize that the importance of having different portfolio to reduce the risk. Again, if you don't know who is Warren Buffett, that's fine. But basically, Warren Buffett has invested in hundreds of companies. That's how he has made so much money, and that is what it is telling. If you don't know, it's fine. Now, if you don't know, we will just ask a slightly different question. So I will now just copy this question again and say, as though you are. I just ask as though you are Venki Ramakrishnan. See, I did not tell Venki Ramakrishnan got Nobel Prize. It knows because it has read everything about Venki Ramakrishnan. It knows that he has got Nobel Prize in chemistry. And it is now telling in a slightly different manner, probably more detailed and more scientific, because he is a structural biologist and etc. etc. It is explaining. Again, I'm not asking you to read it right now. I'm just telling you the kind of multiple personality disorder, though it's a feature here, that it can have. So okay, this is fine. But then I will ask as though you are Vadivelu. A famous comedian. So now, Ayo, see, it starts with Ayo, PCR, huh? It's like cooking up some comedy on stage, but instead of jokes, you are making copies of tiny DNA stuff. See, the delivery mechanism of telling the same concept is completely different. So what I'm getting to is, by listening to the same question but slightly different ways of answers, you can understand the concept a lot better. So this is the greatest advantage that it can, you can utilize this to your own advantage. I'll just go back to my slides. I just shown you how it can answer very differently. And now I want to show you for the image generation part. What I have shown you is the text part. I want to show you for the image part. I have already done some images. So this is one of the famous temples in Coimbatore called Maralmalai Temple. And it is a very beautiful blue clear sky. But I want to see how it would look if Himalayas was here. I asked, can you place Himalayas in the background? And it has placed the Himalayas in the background. I know it is not possible. I know it's physically not possible. But why should I constrain my own imagination? Physical possibility is different, but imagination is different. I can still imagine as though there is Himalayas in the background. So similarly, if this is a beautiful beach, yes, there is cloud here, but I know I want to replace cloud with the beautiful aurora borealis. This is a phenomenon that is usually seen in the near Arctic region, like Norway, Sweden, etc. I asked it, can you replace it? It has replaced. And I said, okay, why don't you put bright lighthouse on beach? He said, okay, I will put it. So in this way, just by text prompting, I'm just typing and telling put it here, and it is able to put. I will actually show you this in a few minutes also. So in this way, I said, okay, I'm going to give a talk to a set of scientists. I want to show these scientists that they can use robots to help them do their research better. Can you generate an image? And he said, okay. It said, okay, and generated this image. I hope you're still seeing the image. So this is completely generated by AI. I did not draw it, and it took about like 15 seconds to generate this. I said, I want to show that a scientist can use robots to do research, and it has generated this in a futuristic manner. So what I will do is, now I'll switch gears and actually show you the demo itself as though you are doing some omics research using generative AI. For that, I will take two examples. You tell me what do you want to pursue today in this, in this demonstration. Do you want to pursue some research for cancer in India, cancer research in India, or vector-borne diseases or pandemic diseases in India? So again, please let me know your thoughts on what do you want to pursue. Is it cancer, or is it pandemic or vector-borne diseases? Based on your response, I will start a project right now and show you what we can do. Again, by the way, I have not done this research before, so I don't know what it will do. But let us see what we can do. I'll just wait for 5 more seconds. Okay, many people want pandemic. Okay, it's nearly 50-50, but there is definitely. Oh, it's already 50-50. Okay, it's a tight thing. But okay, let me go with pandemic. Oh, okay, I'm changing. Okay, people are changing. That's fine. Okay, we will go with whatever you choose. We will go with cancer. So I will jump back and open another thing and start cancer research. To do cancer research, I need to understand some statistics. So I will ask ChatGPT whether you can help me understand what is the state of cancer within India, and help me where are the biggest gaps. For this, you can actually do this in free version, which is what I just showed you. But to show the capabilities, I'll be using the paid version that I am paying. But you don't have to use it. You can still do most of it in the free version also. So I'll just going to give an question. Yeah, I'm going to ask, what cancers provide the biggest mortality rate in India? See, it is going to do the research. See, it is biggest mortality rate as of 2024, like right now. I know somebody is not muted, but it's okay. So it is telling me various things about mortality rates, etc., etc., and it is also telling me, etc. Yeah, overall cancer version. Yeah, okay. I will just ask one more, just to restrict it further. What cancers are more? So I'm asking what cancers are more predominant or prevalent in South India, and provide me with proof and citations. I simply cannot use it as is. Okay, in South India, lung cancer is more prevalent, and it is telling me it is more consistent observed in other parts as well. In women, it is for men. In women, it is breast cancer and cervical cancer, which are more consistent or more common. Okay, because it is lung cancer, I will just ask what current anti so I'm just asking what anti-cancer drugs exist. I think I know some of it at least. There's giftinib, erlotinib, and imatinib. Provide me structures of these drugs. I'm going to ask that as well. Like I'm not only asking what cancer anti-cancer drugs exist, because I know that imatinib, erlotinib, they are all anti non-small cell lung cancer therapies, and they're basically tyrosine kinase inhibitors. EGFR tyrosine kinase inhibitors. It is as I said, gestinib, etc., etc. It is telling me various things about the particular drug, various drugs. Okay, let me see if we can. Can you draw the structure of giftinib? I'm asking, can you draw? I mean, I could also search it on the Google, but which I will do probably, because I want to know whether it is actually telling me the right thing or not. So there is something called ChemSpider. I will go there and search. It's a database. Let it search. This is drawing the structure here of giftinib, and then I will be able to see whether this is true or not. So what I'm doing is, basically I'm doing a lot of research. I'm trying to understand where are the gaps about a particular kind of cancer. We went to cancer all over India, and then southern India. Okay, it has some problem. Oh, okay. It is telling me RD kit is required. Again, I don't know how many are familiar with chemoinformatics or bioinformatics. RD kit is a tool which can generate these structures in many formats, like mole format, PDB format, etc., etc. And it already knows it, and it is telling me that you will need that thing. Let me see what it has. Yeah, this is the Smiles representation of this drug. We can see this is whether it is consistent or not. I will just ask. I'm just asking, can you draw the 2D image based on the Smiles notations? So what we did is all cancers, South India, lung cancer, various cancer treatments or drugs that are available, giftinib, and now I'm looking at giftinib structure directly. It is telling me it's not able to join. Again, I said, as I said, I'm doing it for the first time, so it is not able to join. That's fine. We can probably ask it to, you use this to and some other software to generate the notations. I don't know what else it is doing. It is just giving me the same Smiles notations. We can see whether this is consistent with we can go to some other place, but we will just stop for here. But I'm just showing you the capability of this. So now let me see whether I can understand what pathway this particular drug is targeting, or this particular is interacting with. What are the target proteins of geftinib? Now I'm asking, what omics studies can I do to understand its effects further? So this is, as I said, this is just a chatbot. At the end of the day, it is just chatbot. It has understood many things, and it is telling me, as I said, it is a EGFR, epidermal growth factor inhibitor. It's a tyrosine. It binds to the tyrosine kinase domain of EGFR. It is telling me, yeah, it is telling me all the kinds of omics work that I can do on this, genomics, transcriptomics, proteomics, many other things, metabolomics. Yeah, so I can also look at the metabolites and see whether there are any differences in the metabolites produced within the cell, which is having this drug and which is not having this drug, which is a control. Phosphoproteomics, specifically post-translational modifications of proteins and understanding it, this functional genomics, many more things. Okay, this is all great. I will ask, where can I, for example, let me just constrain myself to transcriptomics. Okay, which databases can I refer to get data on comparative So I'm asking which database can I refer? I'm assuming there's something called cancer database. I forgot the name. Cancer Atlas, Cancer Genome Atlas. It is telling that I can go and get it. In fact, I did this work a few minutes back, and I have actually got some data from there. So it is telling various sources where I can get data directly from this, and then do some analysis. So it is telling various sources on where I can get the data. All of this is freely available. Most of these are freely available. You have to understand. Okay, all this is great. I want to just move on to another slightly different one. Let us say I will get the data which is generated using nanopore technology. Nanopore is a kind of sequencing. I don't understand nanopore, so now I want to understand whether can I learn nanopore technology as somebody who have no clue about what is nanopore technology. I will tell you are an exception. I'm telling you are expression bioinformatics. Explain the steps, the principle of I'm telling you are an exceptional bioinformatician. Explain the principle of nanopore technology, because I don't understand. I need to understand how nanopore work, because most of the sequencing nowadays are done by RNA-seq, nanopore, or various other things. And it is explaining to me what are the steps involved in this nanopore technology, so that I can understand this. So again, I'm just learning newer and new technologies, so that I can better understand the data that I get from some of these databases. It could be EMBL, EBI, whatever. There are many kinds of databases which provides RNA or DNA genomic transcriptomics data. So it is explaining to me all the steps involved, or at least the principle of what it is. Again, you can read it. Again, I'm not expecting you to read it right now, but I'm just showing you some of the capabilities of this. The whole intention is for you to get started immediately. I want you to start using this and exploring this immediately for your own research, whatever you are doing. Now, okay, all this is great. Can you draw a flow chart of this technique? I don't know whether it is capable of doing it, but let me see. I want to know pictorially whether it is capable of drawing a flow chart of nanopore. It might not be accurate, it might not be perfect, but let us see what it has to offer. So here I'm showing you the generative AI capability by generating image based on the text that it has provided. Like, I'm tethering many generative AI capabilities together. First I asked a concept to be explained, which is a nanopore, and now whatever explanation it has given, I'm asking, based on this explanation, draw me a flow chart. So it is, see, it has written a flow chart. It is crazy. It is crazy. Again, I don't know whether it is true or not, but the fact that it has done this is completely amazing, including structures of amino acids, bases, etc. It's completely crazy. We will come to it whether it is right or wrong at a later stage, but this is the capability of generative AI. Now I just want, let us assume now we have understood nanopore technology, and I have also downloaded some data sets from one of the cancer databases. What I will do is I will just copy a prompt and paste it here. What I have done is I will upload a data. I first of all probably show you the data. This is just a data that I have taken from one of the databases on cancer. So it is downloaded today from EBI database. It is a gene query result shown here of various genes that are expressing. I'm not sure if you are able to read this, but I'm not expecting to read it. And there are various expression systems that are studied here on the left-hand side, and it is telling what are the relative expression of particular genes in these systems is what is mentioned here. So now I will upload this data, and I will ask ChatGPT, can you explain this data for me? So I'm just uploading it data. Yes, and I'm telling that I have uploaded this from whatever region, say cancer cell line encyclopedia. Can you explain and analyze that, provide a summary of this data? So I'm now using this as a data scientist. I'm not a data scientist, okay, by the way I am, but let us assume I'm not data scientist. Now with the data, I'm asking, can you explain what is happening here from the data? And I'm setting in the context that it is RNA sequence data from this particular place. It probably has some error, but let us see what it has to offer. To better understand properly, load the data, you will need closer look at format, etc., etc. It is going on explaining these things, but it is trying again. Initially, it struggled to do, but it is trying again. And let us see what it has to offer. The first few lines of the RNA data provided clues about its structure. The metadata is the headers, timestamp, etc. Again, I did not tell anything about the format. It has managed to understand these things directly from here. And then it is explaining to me the following header, expression data, various cell lines. See, it's now able to understand that it actually has cell lines. On the x-axis, that is cell lines, and the right, y-axis is cell lines, and the x-axis is all the genes that are expressing. It is going on. I don't want to delve too much into this in the interest of time, because I have to show you one other important feature. Let it go on, but I will just jump back to the slide again. This is for you to just understand the capability of what it can do. Okay, so I'll just wait for this to finish. Probably not. I'll just jump back and go back to where we were. So now I'm just showing you how these generative AI bots can be your right hand to help you with your research in many ways. Probably you're already thinking like, oh, if it's possible of doing all these things, will it replace human beings? So to answer this question, can AI replace human beings? We have to take a small test, which we will do it right now. What is AI doing? As I said, all these LLMs are just bots. No, they're all algorithms. It has learned a lot of things, and now it is predicting. It is generating answers. Can we do it? So as human beings, let us say I tell you I ate an apple on Monday, 2 apples on Tuesday, etc., etc. This is the data that I'm providing. Can you say how many apples I have ate on, say, Saturday? Okay. Probably you can immediately know that, oh, I should have probably had 6 apples. So I did not tell you how many apples I ate on Thursday. I'm sure you know that it's probably 4, which is correct. Now, based on the data that I have provided, you are also predicting. This is what humans are also doing. Now I will give you another exercise. Keep your mobile phones next to you. So here I'm telling some, giving you some data. I'm asking you the question whether person 1 is better or person 2 is better. That is the question. You have to tell me who is a better person, who is your hero. I'm giving you the data. The data is person 1 had one wife plus, but person 2 had only one life partner whom he eventually married. By the way, these are real people. They are not imaginary people. They are people from history. I'm sure you would know these people. So on lifestyle, this person was into drinking, heavy chain smoking, heavy meat eater, all 3 times a day, etc., etc. But this person was very conscious about their diets. So given this information, this is the data that I have provided. You have to tell me whether you choose 1 is a better person or 2 is a better person. You tell me who is your hero, 1 or 2, based on the data that I have provided. Just to tell you, the 1 person has many mistresses, heavy chain smoker, heavy meat eater, etc., etc. But the second person is complete opposite of all these things. And I see nobody voting for 1, which is obvious, right? Based on the data provided, I am sure 2 is your hero. Now, I will show you who these people are. It is Winston Churchill and Adolf Hitler. By the way, this is all facts. What I did was I tricked you because I did not give you more information. I gave you only some selected data. If I had also told that this person is responsible for winning World War II, he was the Prime Minister of UK at that time, and if I had also given you this data that this person killed millions of Jews, probably your answer would have been very, very different. So what I have done is I have tricked you into intentionally doing or selecting somebody who is probably not the great person at all. But by giving you selected data, this is very important because AI actually has this problem. It has no understanding of what it doesn't know. For example, some of you might not know swimming, but you know that you don't know how to swim. That information is very, very important because you know that you cannot swim. You will not go and jump into the middle of the ocean because you know that you cannot swim. But generative AI and generally the current state of AI is it only knows what it knows. It doesn't know what it doesn't know. If that is the problem, then whatever answers it gives will probably fall into the same mistakes that we humans just now we did, because the AI can be easily tricked. We cannot completely believe it all the time. I'll just give you another example. Same thing. I'm giving you data. The data is person 1 killed 3 million people. Person 2 is responsible for bombing parliament. Who do you think is a better person? Person 1 or person 2? Who do you think is a better person? Yeah, I think somebody has already answered this one. I don't know whether it will change or not, but I'll just wait for a few seconds. So the person 1 killed millions of people. Person 2 responsible for bombing. So now, who do you think is a better person? I don't see anybody voting for 1. I'm assuming everybody is voting for 2. With that assumption, I will just go forward and then again show you the true faces behind 1 and 2. So 1 is again Winston Churchill. You might be wondering, what's happening here? Obviously, I don't think I have to tell who is Bhagat Singh. If that is the case, then I feel terrible. Bhagat Singh is one of the greatest freedom fighters. So Winston Churchill, though he was responsible for winning World War II, he was also responsible for millions of deaths during the Bengal famine, when India was a colony of UK or British. And he did not take the necessary action to save all these people. And that is why he is also responsible for these people. So what I'm getting to is the right and wrong that you chose can be completely different depending on the context. In the previous slide, you picked Hitler, but then I showed Winston was hero. But now I'm telling Winston is not the hero after all, because the context has changed. This is also true for AI. Whatever data you provide is the only context it has. It has no memory or knowledge of what it doesn't know. Only humans have this information. That is why I strongly feel AI cannot replace humans yet. With that, I just want to summarize. What have we covered so far? I have only covered a tiny bit of a iceberg. I've just taken ChatGPT because most people are familiar with it, but there are so many other things that are available. Some of them are even free, but you might still need a little bit of programming to access these. That's why I have not covered it today. I wanted it to be very easy so that you can try immediately after this demonstration. And what I showed was very easy use cases, very trivial: cancer, Jeftinib, erlotinib, EGFR. They're all very known cases. You can actually work with more difficult cases also. But you have to figure out what you want to work on. And based on that, if you start using this, then you will also understand that there are many other ways of asking questions called single shot, multiple shot, zero shot, etc. Once you get into it, you will understand. And there's also a whole area of something called RAGs, retrieval augmented generation. It will enhance the accuracy of getting the data. And I did not even cover these things. And as I said, showed just a little bit of data science capabilities that AI can have. But if you couple this with programming, for example, if you're already using R, if you're already using bioconductor to do some bioinformatics work, then you can greatly enhance your own capabilities by asking ChatGPT to write R programs for you to do the analysis. That is a lot easier for ChatGPT instead of just directly doing it data science. All these things can be done. And as I just showed you, there are definitive limitations. And the limitations are because of humans' inability to use AI well. Not because AI is terrible or whatever. It is because humans are terrible at assessing things, at least as of right now, about AI's capabilities. We use it in wrong ways, which can become limitation of the AI. And as I said, AI cannot replace humans, but humans using AI might replace humans not using AI. So it is up to you to figure out whether you are the person who will be replaced by somebody because you are not using AI, or whether you can also do many other things by using AI. It's up to you. This is the summary. But I'm a human being and I want to take feedback. So I really request you to go and scan this image and provide your feedback. This is a different image, not for the polling. This is a different image. You will have to rescan this. And with that, I will thank Alex and Fatima, whom I have known for many years, and the organizations Biomall as well as Azooka. And I am open to ask for any questions you might have. Thank you very much. I'll just leave it for a couple of seconds so that you have a chance to send me feedbacks. I really look forward to receiving your feedbacks. Thank you. Thank you, Alex.
Yeah. Yeah. So thank you, Kaushik. That was a really amazing demo. I think this is what we wanted to really wanted to go with. We wanted something which is a conversation. So I would also like to thank all the audiences for coming in. So if you have any questions, you can ask Kaushik Hatti. I don't want to stand between. I want to keep it conversational. And before I go further into the questions, I would also like to welcome a special thanks to Shekhar Suman from Biotechnica for joining. Are you still there, sir?
I think he has left.
Left, is
He's
it?
not there.
Yeah, no worries. So guys, if you have any questions, students, so you can get started with your questions. So to ask a question, please click on raise hand, and then our admin team will.
Yeah, I just want to emphasize, asking question is a very much human ability. So if you think you are human, you should ask questions.
Yeah.
I think somebody raised.
Yeah, somebody raised hands. Can you start asking the question, please?
No, we have to unmute Saurish.
Yeah, Shika.
Soresh, you can unmute yourself and ask the question.
Yeah, very good afternoon, sir.
Good afternoon. Thank you.
Yeah. So we have been, for the past few days, we have had been working closely on a project, and we have given that particular project the name Dr. Zoo, the voice co-pilot, and we are working in collaboration with Azooka Lab. So we already have Alex, Fatma ma'am, and then Shikha on board with us. So, sir, I have a few questions that we are encountering right now while working on this particular project. So, I have categorized them into 4 domains. The first domain is regarding data storage and management. So, it is about the scalability and efficiency. Now, given the anticipated influx of data associated with the voice copilot project, what scalable and efficient data storage solutions can be considered? Can distributed cloud storage platforms ensure optimal data access and retrieval while minimizing hardware and cost constraints? So this is the first domain.
Okay, Kishan, do you want me to answer this first?
You can go ahead with the answer first, right?
Yeah, can I?
Yeah.
Yes. Yeah. So it's a very very important question, and the answer is likely to be very long. I don't think I'll be able to answer it in great detail right now because I need to understand the context further. But from what you have explained, I'm assuming you are storing voice data. Is that correct?
Yes, sir. Absolutely.
Okay. So if you are storing voice data, you know one of the important things that I can think of is voice compression. There are many algorithms which can do compression. So with that, you can greatly reduce the size of the file itself. So you might have to figure out what hertz are you storing, how much are you storing, etc., etc. That will greatly reduce the size of the data. The second thing is there are already many algorithms, deep learning algorithms, which are very good at recognizing voice. I can point you to some after this call, which I had tried, wherein if you are interested in identifying voice, like if it is my voice or either your voice or Alex's voice, there are algorithms which can already do it, and they have been already fine-tuned to do it. So you can use this and then quickly identify. But if you want to look at the conversion of how you go from voice to text, then again there are also other set of algorithms. And I had recently read a paper which was generated by a set of scientists from India, so that these algorithms are specifically meant for Indian context. Like we have a specific way of pronunciating some words, and these algorithms are good at picking Indian accent English. So yeah, these are some of the places where I can think. And if it is a much large data set, then you have to figure out probably cloud platform and then work with it. Yeah, that's all I can think of right now.
Okay, sir. Thank you. The second domain that we are facing problem is regarding the automated calculation and explanation. So when an AI or chatbot is answering to my question, especially if it is involving scientific calculations, so during that the problems that we basically face is the symbolic reasoning and formula manipulation, like how the voice copilot can be equipped with symbolic reasoning capabilities to accurately interpret, manipulate, and solve the equations that have been presented by the users. Most importantly, how can natural language processing techniques be combined with symbolic math libraries, enable the copilot to understand the user queries, identify the relevant formulas, and perform step-by-step calculation on behalf of the user?
Yeah. So for this, I would start. I don't think one specific AI can do this currently right now. This comes in the context of multimodal AI capabilities. There are already multimodal capabilities. ChatGPT is one such thing, wherein it can understand voice, it can understand text, it can understand images, many more things. It can do all these things, but it's still not. It's not probably there with respect to mathematical capabilities that you are telling. There are other algorithms which are specifically, again, deep learning algorithms, which are specifically trained for symbolic regression, which is a mathematical representation of logic. So one I can think of right now is called Feynman AI. This was released in 2017 or 19 something, a couple of years back. It's not very new, but I remember using Feynman AI. It's a specific for generating algorithms, generating equations based on the data, wherein if you just throw a bunch of data, it will analyze the data and then actually write the equation for you. So Feynman AI has done some incredible things. It has discovered new algorithms, new formula and new symbolic regression methods, which classical physics has missed for like generations. So probably you will have to tether a couple of such specific narrow purpose algorithms and then use it for your specific use case. That's how I would start.
Okay, sir. Another thing that we are facing is regarding the interactive user interface without installation. That means the problem regarding installable and invocable apps. Now, how can the AI be made conversational and the interaction be conducted in a much more natural language? So how can the voice copilot be equipped with advanced conversational AI capabilities to engage in natural and intuitive dialogue with users? Can deep learning models be trained on scientific language understanding tasks to support seamless interpretation of the user queries, context awareness, and error correction?
It's a very good question. I would actually ask ChatGPT this question and see what it has to answer. I don't have an answer for this.
Okay, sir.
Yeah, this is how I would start. Yeah. Go on. Is there anybody else who wants to ask a question?
So, Kaushik, I want to kind of refine that question because I'm also teaching a class or a webinar or a workshop in which we organize them into groups. So, to make it easy for students, see, here is what the end goal is. The end goal is an invocable in the Play Store, in the Android Play Store. Okay. And we have to start somewhere training the algorithms to get there and voice to get there. So if you can probably, maybe even in the next class, if we can break it down into, for example, there is a group that is focusing on entirely cosmetogenomics. It is a nutraceutical plus a cream. There is cell biology. Probably what we should do is, if the end goal is an app, then how should you use ChatGPT or AIs to get there is maybe it can be set as a context.
Yeah, probably we can have a longer discussion on it. See, it's just for the for the initial onset, it seems more to me as a software challenge than a generative AI challenge directly. However, now as I showed, AI can be used for anything. You can still probably ask AI how to get this, how to solve this software engineering challenge, and then see where it can go.
Yeah. So I think in the interest of time, I think we will kind of conclude with this. So maybe I can close it with this, saying that we have the next. What we have tried to do is we've tried to kind of bring two different, I should say, pillars together, which is going to be informatics and Gen AI. So the next class will be by Kalaivani. Probably will introduce her later, and we'll kind of, if you have any questions that you want to cover. Generally, we've identified a few topics from transcriptomics, some of the omics that are related to IVF and all these centers. So we will come up with a general study, but if you have anything specific, because each of you are in different projects, right? So one is in deep cell biology. So you should kind of line up your questions towards what you want to get started with. So with that, I would like to thank Siddhi. Do you have an announcement to make to close? So thank you all for coming in. I think we'll get the notifications. I think some of the Our Squarespace, I think, kind of failed. Most of you might have got the notifications late. I'm sorry, I apologize. We hope to fix it in the next cycle. And it is a clear unconference format. So I expect a little more of questions because what we are trying to do here is we are not trying to do a monologue where somebody is talking about a concept. Okay, what we tried to do today was solve a real problem in cancer, and it was going like 7 levels deep or more level deep. So what I want you to do is want most of you who are here to apply for a big BIG grant. So we have to kind of break it down into how will you write the technical concept note, how will you write all this. So prepare your questions because you have a goal to complete, you have a timeline. So I would invite you to be more interactive and prepared with more questions. Okay, so Siddhi, do you want to close?
Yeah,
Yes,
I think
Diksha.
before Siddhi closes, I'll just take a moment to personally thank Kaushik. Kaushik, nice to see you after so many years.
Nice to see you.
And yeah, and thank you very much for doing this for us. And personally, as you know, I'm very bad with software and AI stuff. I'm looking forward to more of your sessions. Thank you so much. Yeah.
Thank you. Thank you very much.
Hello, sir. Siddhi here.
I see. Yes.
Yeah. So firstly, I just want to thank you, for your time and the demonstration, like, how you explained with all the cool examples, which made it easier for us beginners to understand. Especially like, we are doing projects, R&D projects in the day-to-day life. So it'll be very much easier for us to understand, to, use such Gen AI tools in the, day-to-day life. So personally, my favorite part was, can AI replace humans? That was my favorite session. So thank you so much, sir, for your time. So this brings us to the end of the first webinar of the 3-part series of Bioinformatics in the Age of Gen AI. So the next webinar on the Bioinformatics is by an expert called Ms. Kalaivani. The registration link for this will be shared by tomorrow. So thank you all for attending and hoping to see you all soon.
Thank you all. Thank you, everybody.